Hello everyone, I'm Singbe Park, a philosopher of science at UNIST, Ulsan National Institute of Science and Technology. In this video, I briefly summarize Chapter 11 of my book, Embracing Scientific Realism. The target viewers of this video are the philosophers of science who have already published and aim to publish more on scientific realism. In Chapter 11, I introduce several new topics for future debates between scientific realists and anti-realists, extracting most of them from previous chapters. The pessimistic induction and the counter-induction for realism conflict with each other. The pessimistic induction holds that since past theories were abandoned, present theories will also be abandoned. By contrast, the counter-induction for realism holds that since past theories were abandoned, present theories will not be abandoned. In what contexts can we choose counter-induction over induction? Exactly how many failures should scientists have before succeeding? Exactly how much improvement should scientists make before making an achievement? Future researchers may want to answer these questions. The problem of unconceived alternatives and the argument from undiscovered evidence conflict with each other. The problem of unconceived alternatives implies that since past theories were displaced by unconceived alternatives, present theories will also be displaced by unconceived alternatives. However, the argument from undiscovered evidence asserts that since a theory has been supported by previously undiscovered evidence, it will continue to be supported by hitherto unconceived evidence. Future researchers may want to resolve the conflict between these two arguments. The problem of unconceived alternatives and the argument from neighboring theories also conflict with each other. According to the argument from neighboring theories, since a theory has been supported by unconceived neighboring theories, it will continue to be supported by unconceived neighboring theories. Future participants in the realism debate may want to resolve this conflict. The pessimistic induction and the optimistic induction over realists conflict with each other. The pessimistic induction holds that since distant past theories were abandoned, present and future theories will also be abandoned. By contrast, the optimistic induction over realists holds that since recent past realists were right to believe the theories of their time, present and future realists are also right to believe the theories of their times. This conflict between the pessimistic induction and the optimistic induction over realists raises what I call the problem of time span. How long should we watch a theory before running a pessimistic induction against it, or an optimistic induction for it? In other words, what is the right time span for running a pessimistic induction or an optimistic induction? Future researchers may want to tackle this problem. Some anti-realists use evolutionary theory to explain the success of science, and some pessimists appeal to evolutionary theory to give pessimistic accounts of scientific development. In Chapter 1 and Chapter 2, I argued that it is incoherent to do so. Anti-realists cannot appeal to a scientific theory to argue the scientific theories are unbelievable. Anti-realists might reply that they can use evolutionary theory for their philosophical purposes, although they cannot use other scientific theories, such as quantum mechanics. Anti-realists who say so face the problem that I called the problem of selection. On what grounds do they select evolutionary theory but not other theories? Future researchers may want to solve this problem. Astronomers predict that the next solar eclipse will occur on a particular date. They specify the time of their predicted event. By contrast, pessimists and selective realists don't specify the time of their predicted event. They predict that present theories will succumb to scientific revolutions, but they don't tell us exactly when scientific revolutions will occur. As it stands, their prediction is not virtuous. I have a blunt question to them. In what year will evolutionary theory be abandoned? Future researchers may want to answer this question. Suppose that physicists and biologists form an interdisciplinary research team and develop a new theory. If we classify it as a physical theory, it would be vulnerable to the pessimistic induction over physical theories. By contrast, if we classify it as a biological theory, it would not be vulnerable to the pessimistic induction over physical theories. Now, it would be subject to the global pessimistic induction, whether we classify it as a physical theory or a biological theory. According to the global pessimistic induction, since past theories in all fields of science were abandoned, present theories in all fields of science will also be abandoned. It doesn't sound right, however. A scientific theory falls prey to a pessimistic induction or not, depending on how we set the scope of the pessimistic induction. Here comes an interesting question. How should we set the scope of a pessimistic induction? Future researchers may want to tackle this problem. Anti-realists construct a famous argument against realism called the argument from a bad lot. It says that even if a theory best explains phenomena, we cannot conclude that it is true because it may be the best of a bad lot, i.e., because there might be better unconceived alternatives. In response, I construct a similar argument that I called the argument from double spaces. Let me first distinguish between the appearance and the reality of a theory. To say that a theory is successful means that it appears to be true and empirically adequate. Although a theory appears to be true and empirically adequate, it might be false and empirically inadequate. So we should distinguish between the appearance and the reality of a theory. Let me now distinguish between two logical spaces that I call the T-space and the O-space. The T-space is the logical space of unconceived theories whose realities are transparent to us. If a theory selected from the T-space appears to be true, then it is true. If it appears to be closer to the truth than its competitors, then it is closer to the truth than its competitors. If it appears to be empirically adequate, then it is empirically adequate. If it appears to be closer to the empirical adequacy than its competitors, then it is closer to the empirical adequacy than its competitors. By contrast, the O-space is the logical space of unconceived theories whose realities are opaque to us. Even if a theory selected from the O-space appears to be true, it might be false. Even if it appears to be closer to the truth than its competitors, it might be farther from the truth than its competitors. Even if it appears to be empirically adequate, it might be empirically inadequate. Even if it appears to be closer to the empirical adequacy than its competitors, it might be farther from the empirical adequacy than its competitors. The argument from double spaces holds that we don't know whether scientific and philosophical theories are selected from the T-space or the O-space. So, we don't know whether they are true, closer to truth than their competitors, empirically adequate, or closer to empirical adequacies than their competitors. I challenge future researchers to show that the argument from a bad lot is strong, but the argument from double spaces is weak. I just summarized chapter 11 of my book, Embracing Scientific Realism. Thank you for watching. See you next time. Bye.